Good morning, students. So today we are going to discuss about subset chapter 1 sets or set theory. So subset. So far we have discussed about set and its representation, types of sets. Okay. So this is also one of the type, that is subsets. So let we have A and B are any two non-empty sets. Okay, A and B we have taken as non-empty sets. That is, A and B must be having at least one element, because empty set containing no element. Okay, then the symbol represents the symbol of subset. Then A is subset of B. We will read as A is subset of, A means A set, subset of B if all elements of set A, all elements of set A are also the elements of set B. Right? So this statement can be written as mathematically A is subset of B if, let us take any small a belongs to A, that is any arbitrary element of this set we are taking as A belongs to A, and this is a symbol of implies, which means implies, that is to indicate. So if A belongs to A, that is if this element small a lying in this set A and A is subset of B, this implies A is also the element of B. So this is what mathematically definition of subsets, that A is subset of B if there is an element A, if it is lying in set A, it will also existing in set B, that is A belongs to B. So this symbol is already familiar. That belongs to means it is lying in that set. So we can say, or we can define, if all elements of set A are also the elements of set B, then A is subset of B. Okay, let's consider one example. A equals to 1, 2, 3, and let's take B equals to 1, 2, 3, 4. Right? So here we want to check whether A is subset of B or not. So see, 1 is in A as well as in set B, same as 2, 2, 3 and 3. So what we have found, all the 3 elements 1, 2, 3 are also the elements of set B, that is 1, 2, 3. These elements are also lying in the set B. So we can conclude as per definition A is subset of B. Right? It is very interesting to notice further. Check, is all elements of set B are also the elements of set A or not? So 1, 2, 3 is here already given, but 4 is not there. It means here we can say B is not subset of A. This symbol means not, which we have processed. So in this set theory, the symbols played a very important role. Not subset. Okay, the symbol indicates not subset. So it means B is not subset of A, as all elements of B, that is 1, 2, 3, 4, are not the elements of A. Right? So from this discussion we can conclude if A is subset of B and B is subset of A. If A is subset of B and B is subset of A, this implies A equals to B. So it means we can also establish the concept of equality of two sets. That if both sets are subset to each other, so in fact this is a very important property which we will be using in proving the theorems and various results. Okay, that two sets are equal. We can say two sets are equal if and only if they are subset of each other. That is, we can write another point. Two, let's write sets are equal if and only if. So briefly we can say I double F, right? I double F. It means this is a brief representation of this line. If and only if means I double F. So two sets are equal if and only if they are, or you can say A is subset of B and B is subset of A, or you can say both sets are, both slash, we can say both sets are subsets to each other. Right, got it? So this is a very important concept, subset. Okay. Now from this definition it is clear. Here some points are to be noted. That, note point first, every set is a subset of itself except empty set. Make sure every set except we are talking about, because already I mentioned, and we are what? Empty set, non-empty sets. It means we are not talking about empty set. So all sets means, every set means, except we are talking about empty set. So every set is a subset of itself. Why? See, let A be any non-empty sets. So, and it contains some elements, right? So clearly all elements of this set, whatever be the set, that is A, non-empty, right, is what? Subset of A. It means if I take A equals to 1, 2, okay, if I write here 1, 2, so clearly 1, 2 is subset of 1, 2, because as per the definition, if this set is a subset of this, I mean another set, it means both elements or each and every elements of this set must be the elements or must be existing here in this set. So clearly the result is obvious. 1, 2 is here and 1, 2 is there. It means all elements of set A are automatically or ultimately the elements of set A. So that is, every set is a subset of itself. This is a very important characteristics, right, to be used in the many exercise problems. So make sure, learn it. And next one is, now I am taking empty set. Empty set, which is denoted by the letter phi. Empty set, that is phi, is a subset of every set. Empty set, that is phi, is a subset of every set. Why? So let's write mathematically, symbolically, phi is subset of any set, let A, B, C, and A, B, C are what? Non-empty set. Okay, phi means what? No element. So in set A there are automatically some elements, and what we have to take here? No element. So if we are not taking any elements, so there is no condition at all to check whether this element lying here or not. Until unless this set having some elements, only then we can find whether this element is lying there or not. So since A is having some elements and 5 means we are not taking any elements, so no element is also satisfying the condition of subset of another set. Okay, so these two are very important characteristics that 5 is a subset of A. So in the exercise there are 3 questions which are based upon this concept. Let I discuss to you. 1.3 question number first. So you will try in all the parts. I am discussing some of the parts. 2, 3, 4. Then fill in the blanks. 1, 2, 3, 4, 5. Okay. So fill in the blanks. So we have to use the symbol subset or not a subset. Right? So check 2, 3, 4, 2, 3, 4. So all elements are lying in this set. So clearly the 2, 3, 4 is a subset of the second given set. The next part, third part, interesting part. X is such that X is a student of class 11th of your school. X is such that X is a student of class 11th of your school. Then fill in the blanks. X is such that X is the student of your school. It means left hand side we are taking the student, which is student, 11th class student of your school. This is the first set, that is A. And the set B is what? Students of, all students of that school. Right? So what do you think? Is this set of class 11th students will be a subset of B, that is the student of all the student of that school or not? Yes. So clearly this part what? That is class 11th student is a subset of all students. Why? Because this is class 11th is a part of all the school. So the student who is the student of class 11th will also be the student of the school. Make sure that all classes constitute or associates with the school only. Right? So class 11, not only 11, even all the other classes like 12th, nursery, even class 1st, 2nd, right? If the school is still senior secondary, that is up to 12th. So each and every student of any of the class must be what? The subset of all students of the school, right? So this is a very interesting part. Next, fifth part I am taking. X is such that X is a triangle in the plane. X is such that X is a triangle in the plane. Because a triangle is a 2D figure, right? Fill in the blanks. The next part, X is such that X is a rectangle in the plane. X is a rectangle in the plane. So now, is the set of triangle the subset of rectangle or not? Just find. So before solving this part, you have to connect, is the set of triangles linked with rectangle or not? No. Why? Because triangle containing 3 sides and rectangle containing 4 sides. So there is no connection at all. So the answer is not a subset. Okay. So same as the 7th part is there. Question number 2 is there. Okay. So you will try question number 1, 2, 3. Right. So and in the next video I will be discussing some more parts. So I am sure you must have learnt about the subset. Today you have learnt. So do practice and solve the examples and ask your doubts. Thank you very much.